So far in this class, you've learned about systems tracks and the sequence stratigraphic surfaces, so you have all the information that you need to apply the concepts of sequence stratigraphy to actual outcrops and stratigraphic sections. The purpose of this video is to cover a few terms, most notably the parasequence and the sequence boundary, that you may encounter in other discussions of sequence stratigraphy in the future. These concepts are not necessary actually for sequence stratigraphic analysis, but they're kind of legacy terms that have been used previously, and so therefore you will potentially come across them in other readings. So if you read about sequence stratigraphy elsewhere, you're likely to encounter this term, the parasequence. A parasequence is defined as a relatively conformable succession of genetically related beds bounded by something called a flooding surface. The traditional parasequence is a shallowing upward succession from offshore to shore face that's then capped by abrupt deepening back to offshore, like in the picture here. The red arrow in the photo points to one of these flooding surfaces, which is unfortunately an ambiguous term. So a flooding surface just requires rapid deepening of the facies, but it can be many things. The flooding surface could be a transgressive refinement surface. It could be the maximum regressive surface if there's little deposition during the early part of transgression. Or it even could be a within-trend flooding surface if transgression actually began in the underlying coarser-grained shore-face sediments. So it's best to identify the surface more specifically as an actual sequence stratigraphic or within-trend surface, and to avoid this ambiguous term of a flooding surface. Until recently, sequence stratigraphic terminology was based on the idea that systems tracks were made up of sets of parasequences. So each parasequence is progradational, that's sort of the typical coastal parasequence, but those parasequences were either stacked in larger scale sets that were progradational or retrogradational. So if you look at this diagram, you'll note that even in the TST, these yellow shallow marine sandstones still prograde outwards during each parasequence, but the overall pattern is one of retrogradation. So somehow within the TST there are little progradational packages, but the overall pattern is one of stepping backwards. So this idea that systems tracks are built from multiple parasequences stacked in either prograding or retrograding sets is unnecessary. It's also somewhat obsolete. So the reason that a systems track being built of parasequences is an unnecessary idea is that sequence stratigraphy is scale independent. If the parasequence reflects a base level cycle, I point out that some parasequences can be autocyclic, like in a delta or like in carbonate sediments. But if the parasequence is a base level cycle, well then it's a depositional sequence. It'll have a low stand systems tract, transgressive, high stand, falling stage. The scale doesn't matter. As long as it's a complete cycle of base level, it will contain the systems tracks, because systems tracks are just defined off of the balance between base level change and sedimentation rate. So finally, some words about this thing called the sequence boundary. The recognition and the placement of the sequence boundary has been a source of quite intense disagreement for several decades after sequence stratigraphy was developed in the 1970s. But the key point that you need to take away is that sequence stratigraphic surfaces, the ones you've learned about, the subaerial unconformity, the maximum flooding surface, the transgressive refinement surface, and so forth, are surfaces that can be objectively identified on the basis of observations and data. The choice of what you make the sequence boundary is entirely model-driven. It's just based on interpretation, like what model do you prefer, what terminology do you prefer. So it's really irrelevant what you choose as your sequence boundary. So this table is just summarizing 5 different models that have been proposed for sequence stratigraphy, how they labeled the systems tracks, where they placed the sequence boundary, and so forth. The details of these are not important because they're just models. They're just different ways of describing or summarizing what we can objectively recognize from the patterns of base level change and the surfaces that arise from that. But if you look at these models, you know that they don't even agree on the systems track terminology, especially in the interval of base level fall. Some call that early LST, some call it late HST, some called it FSST, which is the standard term now. The transgressive regressive sequence model on the right-hand side even just used 2 systems tracks, either regressive or transgressive. So in any case, the depositional sequence is cyclical. right? It falls, and then it rises, and then it falls again, then it rises again, then it falls again. So you could choose any surface to divide one sequence from the next. And it's actually somewhat of an arbitrary division. I mean, you can choose one point, and that'll divide one sequence from the next. As long as you're consistent, it shouldn't really matter. But it is presumably best to choose a surface that is easily recognizable and that's more or less synchronous. So you learn that the maximum regressive surface and the maximum flooding surfaces are diachronous across their length due to sedimentation rate variations, so that they can be diachronous. It turns out that the regressive surface of marine erosion and the transgressive revealment surface are even more diachronous across their length. So therefore, the best choice for a sequence boundary, if you're going to choose one, is the subaerial unconformity and the correlative conformity, which is the offshore equivalent or the offshore continuation of that. The key thing for your sort of workflow, if you're doing this, is to identify the objectively recognizable surfaces like maximum flooding, transgressive revealment. These are the surfaces that are going to divide the objectively recognizable events, like the onset of base level fall, the end of base level fall, the end of regression, the end of transgression. Those are events that are real-world events. Where you choose to place the sequence boundary is much, much less important than that. So focus on the surfaces that you've learned about and the system tracks you've learned about, but just keep in mind that you may come across, especially if you're reading older papers, debate about the sequence boundary or terms like parasequence.